Hello, everyone. Um, Welcome to the premier project presentation of the Data Science Internship for 2022, brought to you by Hamoye. My name is Mercy Okwadokun, and I'm an editor at Amway. Okay, I'm joining you from Ibadan, Nigeria, and I will be your host for this session. Okay. The mission of Hamoye is and has always been to develop an army of problem solvers through our internship-style training in data-centered careers. And we pride ourselves as having been successful with this mission, and it gives even more joy to have interns in the fall 2022 cohort of the Hamoye Data Science Internship perform machine learning wonders with data sets from different domains, including security, gender, health, divorce, and so on. Our interns got the chance to work in cross-functional teams on what we call premier projects. They selected topics of their choice, sourced for datasets, analyzed them, provided insights, as well as built and deployed models. They are now ready to share their findings with you. In a very special way, I would like to welcome members of the different data science communities here present, Amway Fellows and Amway Internship alumni, and our incredible interns who have made it this far. A big congratulations to you for the great and excellence you have displayed so far. I'd also like to welcome our judges, Shivam Rafael, who is currently leading a lead data scientist in Amway at the Amway AI Labs, an Amway Fellow, and holds a Master of Technology in Artificial Intelligence and Robotics. His area of expertise or interest include NLP and Kafka, Influx, DB, and ML algorithms, data analysis, financial data science, and Android development. Hello, Shivam. Thanks for joining us.
Yeah, hi, Mercy. Thank you for having me.
Yeah. We also have Basil Ihoma, who is an astute data engineer, Hamoye Fellow, and an MLOps engineer. His area of expertise or interest include data science, machine learning algorithm, and operations. Both of our judges are alumni of the Amway Data Science Internship 2020, and being former interns themselves with years of experience under their belt, they have a lot to give in advice, critiques, and fastidious examinations of every group's work. It's a session worth looking forward to. And now, without further ado, I will hand over to my colleague, Daniel, who will be taking us through the presentation and the rest of the sessions. Over to you, Daniel.
Hello guys, my name is Daniel Coming. So just before we go into the presentations proper, please take note of the following. Each team will only have 5 minutes for their presentation. You will be given warning to round up at the 4 minutes, 30 seconds mark and stopped once your 5 minutes is up. So we need to take note of that. Timing is very important for this presentation. If a team is not available for its presentation at its allocated time, that team will forfeit their presentation. So everybody needs to be ready to present. At the end of every presentation, we will hand over to the judges for their questions and comments. Feel free to use the comment section for your comments and contributions. And finally, dear presenters, try your best to be concise and straight to the point. Remember that you have just 5 minutes, so don't beat around the bush, don't waste time on the preliminaries of your project, just go straight to the point so that you can get through in time. Thank you. So we're going to start immediately. The first team that I'll be presenting today is Team Azir. Team Azir, are you there?
Good afternoon. Good afternoon. Yes, I'm here. I'm going to share my screen now to begin.
Okay. You can start when you after your time. Okay. Thank you.
Okay. Yes. Please confirm you can see my screen.
Yeah, your screen is visible.
Okay, thank you. So my name is Adidamola Adidoyi, and my other team members, the names are right there. I'm the project lead. The assistant project lead is also available on the call to answer any question in case the question arises. So the data set we worked with was, so the problem statement for our project was to evaluate a particular data set of customers that are likely to churn. That means that are likely to exit a subscription or stop subscribing for a particular program. So we were trying to predict this set of customers and identify them. And so the existing solution, running through quickly. So the existing solution for the company was to spend a lot of money to retain, to acquire new customers. So in order to reduce the cost of acquisition, we had to look for a model to help them retain their existing customers, because spending money on retention, the money spent on retention is usually far less than the money, the sum spent on acquisition per customer. So our approach was to gather the data from Kaggle. We cleaned the data using a number of steps. We explored, Okay, so the exploratory analysis, then modeling, evaluation, and validation, then model deployment. So for the data set had about 10,000 rows and a number of features which are listed here. Because of time, I wouldn't go far too deep into that. We had to do some cleaning. We removed some unnecessary columns like the ID columns. and some other columns. We also removed the unknown values, which are more like the null values, right? Yeah. So we also did some sorting, and then we displayed the numeric data, a visualization for the numeric data, and then also for the district data, like the gender and the marital status and that. So finally, we went into the modeling. So the first thing we did was to split our data into the training and the test sets. We did 0.2 for the test sets. Then we used a number of models initially, and of the models we used, we found out that the light gradient boosting machine, the LGBM classifier, gave us the highest accuracy at that time. So we decided to go with that and explore that further. So our original model gave us a 97.2% accuracy, but we didn't just stop there. We needed to go deeper, because the fact that the accuracy was this high doesn't actually correspond to the fact to a very good model, because originally our model was even imbalanced, right? We had far less our positive class, which was the customers that churned, were far less than the negative class. So we needed to do use our in-blend. We needed to balance our data, so to speak. So because of that, we couldn't depend on the accuracy. So we had to use another metrics, which was the recall. So the recall for the first model was 0.8, so 0.68, that was about 86%. So we needed to, so this is what we have visually, and we also had a list of the top 10 features graphically over here. Then the recall, as you can see, 0.68. Then we have a display for the confusion metrics. Then we did the hyperparameter tuning, changing the number of leaves, the depths, and all of that, did some tuning, and then we increased the model's accuracy from 86%.
30 seconds left.
Sorry, the recall. Yeah, so we increased the recall from 86% to 91%, which, although the precision reduced, but we were able to, so this is what we have for the tuned model, and also all of that. Then we deployed the model, which was just putting the model in a pickle binary file for deployments, which can be used in publications and all of that to predict.
Your time is up. Thank you.
Data.
Thank you very much.
Yeah, thank you.
Okay, so Shivam, can you please help us to this presentation?
Thank you, Daniel. So just a quick question. You mentioned about the class imbalance, right? So
yes.
Can you tell me how did you manage that?
Okay, so for the class imbalance, we used a library from InBlend. Imbalance, yeah. So what we did was we used an oversampler to do an oversampling of the training set and the test set.
Okay.
So of the training, yes, of the training set, we left the test set. The test set was untouched. So we used an oversampler to oversample, a resampler to oversample the test set. Yes.
Okay. And you have also talked about the hyperparameter tuning, and you have stated that it improved your recall from 86% to 91%. So can you just state me the exact hyperparameters that you tuned?
Okay, so what we did was we increased the number of estimators. Yeah, we increased the depth of the tree. The LGBM is based on a decision tree algorithm, so we increased the number of depths for each of the trees and the number of leaves also.
Okay. And
yes.
What was your conclusion regarding this entire project? What is your outcome out of it? Like
okay.
what could be the real world scenario for this project?
The what?
The real world scenario.
Okay, for this project, Okay, for this project, according to the recommendation I gave, we've only had about 10,000 observations. We could actually increase that to help our model perform better. But for this particular project, as you can see here, the 19 there shows us that, okay, from our recall, we were able to get a very good recall, meaning that we're able to capture at least 91% of those that are likely to churn, even though the 19 there, which is the false positives, right? The false negatives, we were unable to exempt those from our predictions, right? But we would still be on the right track to actually target the whole 193 and also the 27 here, right? So we predicted 193 and 27 in total to churn. We were wrong in predicting the 27, meaning the 27 should have, the true label for the 27 was actually for the negative class. But from our prediction, even though 27 were inaccurately predicted, we still had a very good recall. So this particular model will be able to predict accurately 91% of the customers that are likely to churn.
Okay, thank you. Yeah, good work.
Thank you.
All right, thank you. So without wasting time, we're going to go to the next team. Team Bitbucket. Team Bitbucket, are you there?
Yes, I'm here.
All right, so are you ready to present?
Yes, I'll show my screen now.
Sorry, there's some kind of noise in your background.
Oh, that would be my sister. Can you hear me now?
We can hear you, just the noise is kind of distracting. But like, yeah, you can start.
Okay. Can you see my screen?
Yes, your screen is visible. So your time starts now.
Good afternoon, everybody. My name is Zainab Ibrahim, and I'm representing these projects from London. So we worked on the movie recommendation, and our project lead is Chukuna Unido, and the assistant project lead is Jennifer. The query analyst is Grishma Hemis. So there are other team members that helped make the project possible. So the statement of the problem is, given that major films costing over hundreds of millions of dollars to produce still flop, the industry is ever curious in acquiring the answer to these questions. And the success of a movie be predicted before its release, and is there a formula for releasing movies with box office success? We also did a recommendation system to recommend movies to users. So the existing solutions to this includes popularity-based recommendation engine, content-based recommendation engine, and collaborative filtering-based recommendation engine. We ended up going with the content-based recommendation engine. This type of recommendation actually takes in a movie that a user currently likes as input. Then it analyzes the movie's content to find other movies with similar content. The metadata for this project includes the genre, director, description, then the actors, and other metadata for the movies. So the data description includes the data set. We have two data sets that includes, the first data set includes the budget, genre, homepage, the overview, and the likes. Then the second data set includes the movie ID, the title, the cast, and the crew. So we, for the data preparation process, we did some data wrangling we collected our data from Hamoye initially, and then we did some data wrangling, cleaning, and then we removed outliers. Then we merged the two data sets using the merge method of pandas. In the data sets, we had to remove two columns because they contained null values. The two columns we removed are home page and the tagline. So later we used the abstract syntax tree, that's the HAST module, to change the data type of some of the features with the list of strings to the Python list for a better understanding of the data set. So we also removed some unnecessary projects. So now straight to the model training. We cleaned, after the cleaning of the data, we built the model using the natural language toolkit, that's NLTK, and then we used the standard, we used Potastemma module to normalize the feature column in the data frame. We also used count vectorizer to find a way to represent the text as vectors. So the count vectorizer module is a tool provided by the scikit-learn library in Python. It is used to transform a given text into a vector based on the frequency of each word that occurs in the entire text. So we also used the cosine similarity module of scikit-learn to find the cosine similarities between the vectors and find out how similar they are to each other. Then as a final step, we created a function that takes in a movie title as an input and outputs at least a list of 8 similar movies. This function will match the input movie title with the corresponding index of the similarity matrix and extract the row of similarity values. After training the model is used to make predictions, and hence its performance was evaluated and validated. Here we inputted a movie called Avatar, and then we got these recommendations from the system. So, and then we compared the results that we got.
Oh, you have 20 seconds left. Sorry, 20 seconds left.
Okay, then we compared the results that we got with a search on Google, and we realized that we got almost similar movies, recommendations for the same movie. So in summary, the rapid growth of the data collection has led to the new era of information, and data is being used to create more efficient systems where recommendation systems come into play.
Your time is up.
Okay, thank you very much.
Your time is up. Thank you. So I'm going to invite Basil to access.
Hi, can you hear me?
Yes, I can hear you.
All right, thanks for the presentation. So you said you sorry, let me get to that. Okay, the existing solutions. So, can you give me a reason why you went with the content-based recommendation engine for this particular problem?
Based on the data we have, we decided to go for the content-based recommendation engine because it has to do with recommending what the user likes, based on what the content that the user likes. So we decided to go for it and use that to recommend the movies based on what the user would like to watch.
Doesn't the collaborative featuring based recommendation do something similar like that?
But the difference between that and this is because the collaborative filter is based on similar users, not what the user uses personally. The content based is more of what the user does, what the user watches, not unlike collaborative featuring that uses what similar users uses. That's the difference.
Okay. So how did you evaluate your model? You said your model, you tested it and it was accurate. So can you tell me how you evaluated it?
Yes, we created a function that was able to give us similar movies. We got some data.
Sorry? like, I just want to know what metrics or how do you evaluate it? Probably I don't know. I just want you to like tell me or explain to me.
Okay, we use the cosine similarity to check the of the module to evaluate the data, the model rather.
Okay, going back to your statement of problem.
Okay.
So the idea or the whole intention of this project is to answer those various questions there. Can the success of a movie be predicted before its release? And is there a formula for releasing movies with box office success? So with your solutions and like all the analysis and modeling you did, do you think you were able to come up with answers to those questions?
With further analysis, we'll be able to do that. But for now, we're able to like create a recommendation system. However, with further analysis, we'll be able to do check that.
All right, that's all from me. Thanks. Yeah, that's all. Thanks.
All right, thank you, Basil. So next team Campus. Are you guys there?
Yes, we are.
So are you ready to present?
Yes, I am ready to present.
Please share your screen.
Are you able to see my screen?
Not yet.
Okay. Because I'm sharing.
Okay. We can't see it yet.
Let my co-presenter share.
Is your co-presenter here? Hello, you guys are wasting time.
Yes, I am. I'm here.
Please share your screen.
All right. Can you guys see my screen?
Yes, we can.
Okay.
So I've started your time. The time has started.
Okay. Well, we are cat boost and we looked at what makes the best tennis player. This is our group members, the cat boost family. Our presentation outline is as shown. Our problem statement, we looked at tennis players being popular nowadays, and actually it is considered among the Olympics sports. But we found that there is little that is known about the top tennis players and their indicators, what determines them. And we wanted to answer that gap by analyzing the data on about the Association of Tennis Players from 2000 to 2007. Our objectives wanted to answer who are the top tennis players. Wanted to know what are their demographic characteristics, and they also wanted to establish what determines them. Our approach, we did the data wrangling and preparation. We merged the tables and dropped some features which we didn't use. We removed the duplicates and missing values, and also formatted our data sets where we found some were float when they needed to be integers. We formatted that. And our target audience were looking at the coaches aspiring tennis players and weak players who want to improve. We downloaded our data from Kego. It had 18 tables and about 49 rows, as you can see from the data description. And from there, we get our results as shown below. We found that the top tennis players of all times, the top one was Roger Federer, followed by Rafael Nadal, as shown in that visualization. We wanted to know where do they come from, where the top players come from. The location, we found out that the top players come from Switzerland, Serbia, and actually found that 3 of the top 10 top players come from Spain. We also wanted to know, is height a characteristics of the top 10 player? We found that only 40% of the top 10 players have the height that is above the average of all players. We wanted to know which surfaces are in favor of the top 10 players. We found that the top players mostly played their matches on the hard surface, and that was followed by the clay surface. We found that the surfaces with the most aces were grass and followed by clay. No, the list was with clay. Then we wanted to know, does the first and the serve win characterize the top 10 players? We found that the top players win mostly the first serve and also the second serve, but the first serve is won twice more than the second serve. We wanted to know, do the faults matter to the top 10 players? We found out that most of the winners face low double faults, except for there was an outlier who is Leighton, as shown on that box plot. We wanted to know the tournaments where these top players have played in, and we put the top 10 tournaments played in. Then we found out that the top 10 players dominate at least 3 out of the top 4 Philippines. And that from there, we made the following conclusion, that the best tennis players win their aces on grass. We also found that the top players, they win their first serve, and when they don't win that, they maximize on the second serve. And we concluded that to be among the top 10 players, it is crucial to dominate 2 or 3 tennis tournaments. Thanks for having us.
Thank you. Okay, Shivam, over to you.
Yeah, thank you. So Team Cat Boost, I just have a couple of questions for you. Can you describe me your data set? Like, I was not able to see the data set properly. Can you just tell me about what exact were the rows and columns? What did they contain?
What the columns contained data futures about tournaments, the winners and the losers, but our analysis concentrated on the winners.
So, okay, suppose I am a tennis manager. So what was the conclusion of your project? How would you put your pitch your end results to me? Am I audible?
Yes, you are. Did you hear the question?
Hello. Team Cat Boost.
Are you there, I guess guys? They are not available anymore. So
okay. Yeah, thank you.
Yeah. Team GPT, are you guys there? Team Cat Boost, you can stop presenting. Thank you.
GCP.
Team GPT.
GCP, you mean?
Team GPT. Team GPT.
I think you mean GCP.
Yeah, that's GCP.
Yes, GCP. Yes, sir. You ready, sir?
Okay, so please present your share screen.
Can you see my screen, please?
Yes, I can. The time starts now.
What's happening? Good afternoon, the anchor, the judges and colleagues. I'm representing Team GCP, and the co-presenter with me is Joshua Salako. So we are working on, we worked on Bitcoin price forecast model, and these are my group members. So the problem statement, so what the things that we wanted to look at, wanted to aid decision making for businesses and trading as regards price of Bitcoin. Also want to forecast the price of Bitcoin using time series model, and the model also should be able to predict the direction of Bitcoin prices with a reasonable level of efficiency. So the existing solutions that we have for these kind of problems is hard-coded trading bots such as the Algo bot. So our approach, so we are not just using can you hear me, please?
Yes, continue.
Okay. Our approach is the two major things I wanted to do was to predict the particular price of to predict Bitcoin prices, a particular price, future price, and also to be able to know the direction. The price, just knowing the price is not enough. The price can be going up or going down. So for us to forecast the future price, we use a GAC model, and GAC model is short for generalized autoregressive conditional heteroscedasticity, and it's a statistical model used in analyzing time series data where the variance error is believed to be serially autocorrelated. So GAC model uses three basic steps. It estimates the best fit autoregressive model. It calculates autocorrelation of the error term and tests for statistical significance. And also to check for the direction of the price, we used a XGB classifier. So this is a description of our data set. We add a data set with Bitcoin prices between January 2012 and March 2022. Our columns included open, high, close, and weighted prices. We did some data wrangling, interpolation of the missing values, timestamp conversion, and resampling. Then we created a target column. The target column is to know whether it went up or it went down. So this is our GAC model. This model built specifically to predict both volatility of financial assets perform quite better on Bitcoin, and this is the graph showing that. Also for our tree-based classifier, that's the XGB classifier. After the creation of the target column, training and backtesting function, the model was trained with 0.54 precision, and here is the confusion matrix of the model. At first we used a random forest classifier, but we got less than 50% accuracy, so we tried to go for the XGB classifier. So to increase the accuracy of our predictions, I think we did not take into consideration public sentiment, and public sentiment is very, very important when it comes to the prices of Bitcoin and also other financial assets. So thank you very much.
Great, thank you. Basil.
Okay, that was a very quick one. A nice presentation as well. So the model you use, you said it's GAC model. Can you hear me?
Yes, sir.
Yeah, I think you go back to your slide, please. You said you use GAC model. To be very honest with you, I've not heard about it before. So when I saw this the topic of this presentation, where my mind went to is a time series data. It's time series problem. So my mind just went to ARIMA, SARIMA, basically. So did you consider ARIMA model? And if you did, why is GAC model better than ARIMA for this kind of problem?
Okay, for that question, I'll be referring to my co-presenter, Joshua Salako. Can you please unmute yourself and answer the question, please?
Is Joshua here?
Oh, he has been removed.
Okay.
So
he was the one that worked on the modeling.
Yes. No, not just him. He and some other people worked on the GAC model. I was into the classifier part. We kind of split ourselves into two. So we had people working for the time series and for the classification model.
Okay. I tried to trace back to the problem, to the business problem, like the problem statement. So the very first thing you stated is to add business and trading for decision making, and to be able to forecast the price of Bitcoin. So did your solution, did he your final solution, did he answer these questions, or did he get to solve these problems?
Yes, it's got to solve it, and particularly for the classifier, it gave us an accuracy of 0.56. Yeah, 0.56.
Okay, so probably I've missed the parts where you talked about your data. Where did your data gathering, where did you get your data from?
We got it from a cargo set, cargo data set.
Okay, I would have loved to see probably a prediction. I don't know if you did any of that. Sorry, just to show a sample forecast, probably to show what it will look like, or the price of Bitcoin will look like probably in the next couple of months. Did you guys try doing that?
Yes, we did. It was part of the codes that we submitted.
Okay.
Yes, it was part of the yes. We tried.
There was no graph or any plotting could show me to see what it looks like, or what the graph looks like.
I don't have that on my system right now. I'm sorry, it's on my phone.
All right. I mean, this was a nice presentation. Thank you.
All right. Thank you, team GCP. So the next team that I'll be presenting now is Git Kraken. Are you guys there? Team Git Kraken.
Hello, good evening, everyone. I'm Christian Tan. I'm the assistant leader of Git Kraken, and I'm here to back up our presenter, just in case she's having technical problems.
Can you guys share your screen?
Sure. One moment, please. Okay. Can you guys see my screen?
Great. Your time starts now.
All right. Okay. So good evening. Good day, everyone. In behalf of Git Kraken, I'm Christian Tan. So I'm here to support our leader, Hannah Kasali. So our topic for the premier project is about stock portfolio performance. Okay, so problem statement, you see, portfolio performance measures are a key factor in the investment decision. So the recent trends in stock market prediction technologies are making the use of machine learning, which makes prediction based on the values of stock market. Okay, so with advancement in machine learning, a variety of algorithms are used for various purposes like data mining and predictive analytics and such. So in our presentation, in our problem, given our data set, we are aimed to efficiently analyze the performance of the portfolio in terms of annual returns, risk, and other portfolio features. And then in sub problems of that is we want to find the relationship between stock picking concepts and performances and discover the optimal combination of weight of stock picking concepts and predict the win rates. So our aim objective is to develop a machine learning model to discover the optimal combination of weights of stock picking, of stock pricing concepts and predict the absolute win rate of the portfolio. Okay, so our approach is divided into 5 stages. So we have data sourcing, data preparation, then model training, then evaluation, and then analyzing the results. So to give you a background of our data set, generally there are 3 categories. So the first category, which is highlighted in yellow, is the weight of the stock picking concept. Here, they have various weights depending on the characteristics of the stock. So there are, let's say, for example, in the first column, it is indicated as a large BP. So BP stands for price to book ratio. So there's a certain stock described by that characteristic. So in the first category, there are 6 different features wherein they base the choosing of the stock, and they designed the portfolio based on those stock. And then on the other 2 categories, 2 highlighted categories. The second one is the original investment performance indicator. It refers to the relative return rates of the firm's stock. And the problem with this is that it does not consider the market's tendency. When we say market's tendency, it's the market's bias towards bullish or bearish. So in order to solve that, here comes the third category, which is the normalized investment which is the normalized value of the original investment indicator. So with this, we get the absolute return rates of the firm's stock. And so with this data set, we run different machine learning models as listed in this slide. And upon running the pipeline, we can see that the highest score in terms of R-squared is the linear regression. Okay, so and as we have observed, linear regression model obtained the best result overall compared to other regression models. So the accurate prediction of portfolio performance is a very challenging task due to volatile and nonlinear nature of the financial stock markets. So in the future, in terms of analyzing other portfolio performances, it would be further improved if we can utilize the much bigger data set. And through this study, we can conclude that it is possible to predict
30 seconds left.
The portfolio performance with machine learning. So that's all. And thank you, everyone.
All right, great. Shivam.
Yeah, okay. So thank you for this presentation. It was a nice one. So can you describe me the data set that you have used?
Okay.
There was so much, like so many weight of the stock picking concept. Can you explain this for me?
Okay. One moment. I'll just get my notes. Okay. So for the weight of the stock picking concept, the features considered a general.
So basically, but just my question is, what were you trying to predict, like using these features?
All right. So so we have in the yellow category, each row represents a single portfolio with that kind of combination of stocks based. So we want to predict which combination of these characteristics could best give or could get the highest win rate using different machine learning models.
Okay. So what were the steps like? Is the data already cleaned or you did some data pre-processing? Did you remove any
Yes,
null values or like what was the criteria to remove those null values?
yes. So here, if you can see, we have the yellow-green category. This is the original investment indicator. So that's the percent measurement of the portfolio. So the problem with this is that it is relative to the what is currently measured. So it does not consider the tendency of the market. So what we did is we normalized the values and then dropped all these original indicators and just used the normalized values
Okay.
using the portfolio features.
Okay. So are you planning to improve this work further?
Yes, but I think since we have established the framework, I think if we can find a better data set, a bigger data set, we can further improve our analysis.
So during your entire analysis of the entire project, were you able to find solutions to your problem statement at the end of the day or not?
Yes, indeed. Here in this table, our linear regression model got the highest R2 score. So so I think by using linear regression and maybe try to derive other models from that in order to get a good result.
Okay. Yeah. Thank you. Good work.
All right. Thank you. Thank you, everyone.
Yeah, thank you. You can stop presenting. Okay, so Team PyScript. Are you guys there? Team
PyScript. I thought GitLab is going.
It's supposed to be GitLab, but like PyScript is facing some. Just let PyScript present now. GitLab will come up next.
Okay.
PyScript. No. All right. GitLab, go ahead, please.
Okay. Hello everyone. My name is Goodrich Okuru, and I will be representing GitLab. Let me share my screen.
Your time starts now.
All right. So we worked on. Can you guys see my screen?
Yes, your screen is visible.
All right. So we worked on a project, Game of Thrones analysis, right? So these are our group and the active members. Now, the problem statement we had, the major one was to predict characters' deaths, right? So before in the process of doing that, we actually wanted to look at some hypotheses. If there are more male deaths, more unmarried people perish, and people who are less popular die at a higher rate. But then these are hypotheses we actually wanted to look at. But our major task was to predict, build a model that will predict characters' dates. That was our problem statement. So these are the existing solution, network analysis for Game of Thrones, sentimental analysis, and the rest of them. Now, our approach, we did data collection, we explored the data, did some feature engineering, then we trained the model, evaluate the performance, and fine-tune the model again. All right, so we were given access to 3 data sets, right? The first one is battle CSV. The second one is the characters that has information about the dates of a character, while the battle CSV has information about the battles that was fought in the Game of Thrones. Then the characters prediction actually has information about all the characters in the movie, right? Then we had to predict from this data set to predict the characters' dates. Then we did some exploration. Then we did some exploration, and we found out that 38 battles was fought within 3-year context, and the highest was in 299 BC. Then there is a visual showing, proving one of our hypotheses that there are more male dates than female. Okay. Okay, we performed some data wrangling, and in the process, we discovered some negative ages. So we made some research and fixed the problem. And we noticed that one of them, the actual age was actually 25, and it was given a wrong age, while one of them, the character was actually not born. So we had to resolve that. And looking at this density plot, it's actually showing the rates of people that didn't see people that actually are alive and those that are dead, and the age range. Then we did some feature engineering. Remember the three data we were given, you were asked to predict characters' date, right? So we were to use the features of character that are actually dead to see if we can predict for those that are both alive at the moment or will probably die. So we did some feature engineering, we cleaned the feature, we created links. These links are actually the battle CSV and the character date. You know, they were not directly linked to the character's information. So we created some variables that will link the information and feature creation. So as you can see in this visual, there are the 4 features we actually created. It's a command that was actually gotten from the battle CSV. In-house warlord was gotten from the battle CSV too. Then this House of Allegiance and House of in-house of Allegiance was gotten from the characters date CSV. So this was how we linked the 2 data on the data description to the last one by creating these features. So in the process of selecting, we noticed, okay, first off, we checked at the correlation between the features and the target variable. And the range we got was 0.006 to 0.2. So we decided to go with features that has correlation of 0.1 upper. Those were the features we went with. Then looking at this heat map, we discovered that there are multi-collinearities between some of the features. So on the notebook, we used the variance inflation factor to sort out those features, and we dropped some of them. Then we fit the data. We actually looked at 5 models, right? Since it's a classification problem to predict if someone is dead or alive, we looked at 5 classification models.
30 seconds left.
Here they are. So at the end of it, we're able to proceed with random forest, and this is the RST showing the graph of the 2 models. And we tuned the model to get these parameters. So after tuning it 3 times, we were able to have some good performance from the model after tuning the model. And we had this performance for the first one, this for the second one, and this for the third one. So in the third stage, the performance was actually great. All right.
Thank you very much.
Okay.
Okay, Basu.
Okay. So this is a good analysis. The only problem I have is your slide wasn't looking great at all. Okay. So like I suppose they're giving templates, you know, and it wasn't just great, but it was a good analysis. So my only question is with your sorry, right. Yeah, there was a call. Can you just reanalysis what you did? You use like 5 there should be 5 classification models, and then can you draw a conclusion from the models you use, and then the arrows call.
Okay, so we looked at 5 classification model as there are. So since it's a classification problem, we decided to look at we decided to focus on this ROC, the receiver operator characteristic curve, right? So we noticed that decision tree was actually not performing well because it's lower than the rest. Then we went further with these 4 that are above 0.7 and perform the confusion matrix for the 4 of them. So when we did the confusion matrix, we noticed that random classifier and XGB classifier are actually performing well because the true positive, it's quite all right. All of them are above 100, but then that's for random classifier and random forest and XGB. Their true negative is actually higher compared to the 2 above. So we decided to proceed with these 2 classifier and go ahead to look at the ROC curve. So that was how we got to this ROC curve. And when we look at it, you know, the one that is going to the top left is like the higher it goes towards the top left of the curve, the better the performance. So we notice that the random forest, the curve is on the outer side compared to the XGB. So that was how we decided to, you know, focus on random forest and do the model tuning on random forest alone.
Okay, all right, thanks. That's all.
All right.
Okay.
Thank you very much, Kasali. You can stop presenting now. Team ISOMAP is next. Are you guys ready?
Yes, we're ready.
Okay, sorry. Can you Team PyScript is PyScript?
Yes, I'm ready. I'm ready. Thank you.
Can ISOMAP just be ready to present next? Every other person, so please, when I call you, be ready to present your screen. I don't want to have to be telling you, please present your screen and all of that. So, PyScript.
Yes, please, can you allow me to share my screen, please? Okay. I hope you can see my screen.
Yes, your time starts now.
Okay. Hi, everyone. Vladimir Williams is my name. I will be standing in for Team PyScript in presenting this project titled Airplane Crash since 1908. Here's a list of the other active members. There is no doubt that airplanes are one of the most frequently used means of transportation in the world. Also, since they transport numerous items, including humans, at a single flight through the air, whenever there is a crash, the damage caused is usually great. What makes it worse is that irredeemable lives are lost. Hence, this project aims to analyze the possible root causes of plane crashes and to develop a ML model to make predictions of the severity of crashes. Existing solutions that can be found across the internet analyze just a few variabilities. However, since lives that are usually lost during airplane crash cannot be ransomed, there is a high need to curtail the occurrence of crashes to the barest minimum. So firstly, we cleaned our data sets and removed some stop words, including punctuations that are irrelevant for the model. Of course, all of this is wrapped in reusable functions. We tried TF-IDF and bag of words for feature extraction, and since the results of the model were not good enough, we only deployed the analysis on Tableau Public. Originally, the dataset contained about 4,967 observations with 17 columns, including the index column. However, during the model building, a new variable was created called severity, which is 1 when the number of deaths is at least 50% of those that boarded the plane, and 0 otherwise. Also, during visualization on Tableau, a new column was created called category, which extracts the reasons behind each crash based on its summary. So the explorations and insights are shown on a Tableau dashboard. I'm sure you can see my Tableau dashboard. This is a category of crash. It is showing the number of crashes involving the civic planes. And it is showing that it is more than 4 times the number of crashes involving the military airplanes here. And this is the visualization of the total number of deaths by aircraft operators. And we can see that many of the deaths observed in this data set many of the crash observed in this data set they are caused by the Aeroflot, and it is about 4 times the number of those caused in happened in the American airlines, as shown by the figures here. Also, it is also important to note that from 1908 to 2019, forced starvation caused the most crashes in history, with over 5,000 fatalities. Also, all of the deaths occurred in the American airlines were caused by forced starvation. Due to time limitation, we're not able to match all the locations observed with the original country. However, with the few that were captured, we can see that Papua New Guinea had the most number of deaths with 73 fatalities. And then we have Afghanistan coming close with 68 number of people that died. We can also see that the least number of crashes, the least number of deaths occurred in both 1908 and 1909 with 1 fatality respectively. And that happened in the month of September for both years. However, the highest number of deaths occurred in 1972 with a total number of 2,796 lives that were lost. And not surprisingly, the number of deaths progressively increased towards the year end, with the most occurring in the month of October. So this is our model pipeline. After exploring the data, we cleaned, performed feature extraction using bag of words, transformed the data, and evaluated about 7 models on the data set. When we applied CFIDF on the data set, the results show that almost all the models were overfitting. And by the time we used bag of words, the same thing occurred. So we now evaluated the models again without the use of neither TF-IDF nor bag of words, and we only used fatality.
20 seconds left.
We only used fatality column and they removed all the categorical columns. The results were still not satisfactory. This perhaps shows that the data set is not suitable for machine learning. And one of the reasons is because of the obvious class imbalance. And we could not even further perturb the data set, this newly created variable, in order to maintain the verity of the data set. And one of the reasons, amongst other insights, it is obvious that Aeroflot needs to improve on their operation, aircraft designs, and capabilities. All aircraft operators and
time is up. Also, time is up.
All right, thanks.
Thank you very much. Shivam.
Yeah, thank you, Team PyScript. Like, it was a good one. I just have a couple of questions regarding the features that you selected for modeling. I think it was the summary that you took for prediction, right?
No, at first we used summary and fatality, and summary is like test-based. That's why we use them.
So can you explain me that feature summary? It contains the textual description of the entire event that took place, right?
Yeah, yes, it contains like the description of what happened during each crash of each observation. And it also helps us in categorizing the causes of deaths. So there are some keywords that occurred in them. So we used like the Tableau to extract those reasons, like fuel starvation, pilots, and all of this. We were able to extract about 6 of them, and the rest of them the ones that we could not classify, we just switched it to others, but I excluded that from this visualization.
Okay. The visualization part and the data storytelling is very good. But where I am stuck is like, you talked about class imbalance. So why you didn't try to improve on that?
Yes, yes, we could not treat the class imbalance because even the target variable, we were the one that created the variable. So it's not inside the data set that we had. So we just tried, we wanted to see if we could use machine learning, if we could develop a machine learning algorithm from there. But then it was not, the results were not satisfactory because the criteria that we used to create the severity column, which is the target variable, is that it is 1 when the number of deaths is at least 50% of those that boarded the plane. So it's just like it is already overfitting the reasons what we want to predict. So we could not
based on your entire work, what can you give the conclusion?
Yeah, so the conclusion is that many of these airports, and I think they need to work on providing fuel for most of their entire trip, so that because it is clear that fuel starvation actually caused most of the crashes. Apart from the military crashes, for the civic ones, fuel starvation actually caused the crashes. So they need to, focus more on providing enough fuel for each of their trips.
Okay, thank you. All the best.
Yeah, thank you so much.
All right, thank you. The next team, ISOMAP. Are you guys ready?
Yes, we're ready.
Please start presenting. Your time starts now.
Hello everyone, I'm Chloe and I'm presenting from Team ICSO. Yes, our project is about Black Friday purchases. Yes, and our project is about Black Friday purchases. So Black Friday is basically a Friday that is after the Thanksgiving in the US, and it traditionally marks the starting of Christmas shopping. Our aim is going to be to use ML models to predict the purchases made by the number of buyers. And then we started our data sets we provided by 2 data sets, one for training and one for testing. And then our data source was cargo. So we started by cleaning our data, of which we got to realize that product category 3 has very many missing values, which is sort of insufficient to carry out analysis on it. And we decided to drop it. We carried out EDA, and we started by asking ourselves relevant questions such as, who purchases the most between the male and the female? And we saw that the males purchase more than the females. And then we also asked ourselves, which occupation has the highest number of buyers? We got to realize that occupation category 4 has the highest number of buyers. And then also which age category purchases the most? We got to realize that age category between 26 to 35 years has the highest number of purchasers with a percentage of 39.92%. Which city appears to have more buyers? We got to realize the city B has more buyers with a percentage of 42%. Then the time spent by a buyer in a city, we got to realize that buyers that have spent 1 year in a city carry out more purchases than buyers who have spent 2 years, 3 years onwards, plus those ones who have spent 0 time in the city. Then also which city a buyer is likely to stay longer. We got to realize that buyers are likely to stay longer in city B, regardless the number of years that they have spent. When you look at this graph, you get to realize that at 0 number of years, city B still has a high purchase. At 1 year, city B still has higher purchase. So city B is a city where buyers are likely to stay longer. And then the marital status, we got to realize that those ones that are single purchase more than the ones that are married. And then the distribution of purchase. Here we are predicting and the products, what is the price range of the products that are purchased more? We got to realize that it's between 5,000 USD and 10,000 USD dollar. And then these are deductions from our EDA. Basically, what I've been explaining above, males are more than the females that were carrying out purchases, category 4, and then model building.
All right, I'll be taking it from here. My name is Larry Sufolamileko. So moving on to the model building part and evaluation. We started the model building part by selecting our features and preparing our data. We firstly try to identify the numerical and categorical features. Then we build a pipeline that handles the scaling and missing values of the numerical feature. Then we move on to encode the categorical features, and then we move on to split the data using transversal split function to avoid biases while splitting. We did not make use of the conventional trained test split function because we observed that might create some biases in our data, as we have a gender, a features named gender. So we resorted to using stratified split to split our data to avoid any kind of biases in the data. And then this is our transformer. We build a transformer to do all the processes, and this transformer do all the processes necessary for the data. Then we call on the transformer to fit and transform the data set to the desired form of data set that can be fed into the machine learning model. Then after that, train different model on the data, and realize that SGB ratio and CAD both perform better among all the models. Then we try to fine-tune the 2 model and realize that CAD ratio perform better. Then we train the best model among the 2 on the test set, then we realize that it performed better, it is not overrating, and then we make a conclusion, we give a recommendation on the analysis performed, then we conclude that the model is not 100% efficient, but
Time is
perform
up.
better.
Thank you.
Thank you. Yeah.
All right, Basil.
Yeah, thank you, Team Isoma.
Right.
So the aim of this project is to use machine learning model to predict the purchases made by a number of buyers, especially during the Thanksgiving period and black markets, right?
Yes, yes.
Yeah, okay. And this is specifically in the United States.
Yeah. What is it?
This specifically in the United States, right?
Yes.
Yes, yes.
Okay, so the data you use, is it kind of specific to a particular region in the United States, or it's generic?
It is generic, not for specific places.
Okay. I mean, since you got the data from, okay, what were the features of the data like? What did it cover?
The features are just like the attribute of each bias that could make to make a prediction. Like we have different buyers that buy and that purchase different products or goods depending on their interest, which also depends on some factors or attributes in them, like their age, city they're from, occupation, their marital status. So we make use of those to make a prediction of possible things that the buyers might be interested in buying and the cost of the products.
Okay, so for this to be effective, your data was ranged from when, from which year to which year? What was the range of the data?
Yeah, I can hear you. What did you say? Sorry.
What was the range of your data? Like from was collected from which year to which year?
That is not specified from the data source.
Okay. And then with your conclusion, what did you conclude?
We conclude on, we make a conclusion on based on the analysis that more attention should be focused on buyers who are single, male, and their occupation falls in for category occupation 4 category, because the occupation, as you can see from the analysis, that they are represented in number, which means they are marked value.
So they are the ones that make most of the purchases.
Yes.
What is this, sir?
All right, that's all. Thank you.
All right.
Thank you.
All right, thank you guys. You can stop presenting.
All right.
Team K means. Team
Okay.
K means. Share your screen.
Okay.
I'm starting your time now. So.
Can you see my screen over there?
Yeah, I can. Go ahead.
Okay. My name is Joshua Lamide. I am representing Team Chemis on the project titled Fake News Detection. And as I've said earlier, here are the team members, and I move straight to the content, then to the abstract. With the increasing popularity and ease of access to information available on various internet and social media platforms, it has become so difficult for us to filter out which of the news is authentic or fake. And at the course of this study, we deployed our machine learning model on news stories and thereby verify the legitimacy of the news. And from there, we can see that most of the fake news we receive in our daily activity, daily, was mostly related to most of the important topics such as the COVID-19 pandemic, political events, and also some utterances. And from the menu, you can see that fake news are articles that are intentionally and verifiably false. Our aim and objective is like leveraging on computational tools and the power of machine learning. We hope to present a method that can be used to regularly detect fake news and also compare the performance of the model. And our objective here talks about using machine learning model to be able to predict whether some news are fake or not, based on the test with an accuracy of 96%. And our method here can be seen with the chart below, talking about data collection, cleaning, extraction, and feature selection, and then modeling the evaluation. And for data collection and description, data sets we will use for this study was obtained from Cargo, and data contains of about 20,800 observations and 5 features, consisting of 4 independent variables and the target variable represented as a binary variable where 1 indicates fake news and 0 indicates authentic news. And for the cleaning, we therefore replace some of the unknown value by empty strings. Then we drop some features that are not actually needed. Then for better understanding of the data, we carry out EDA, and from there we can see that most of the news we have here, we have true news and the fake news, and we can see the proportion of the news are almost equal. Then we talk about the n-gram analysis. We can see that most of the words for the unigram are for the true news. You can see that Trump has the highest frequency, followed by said for the fake news, and then we also move down to the bigram, then to the unigram, trigram, and the rest. Then for the word cloud, you can see that for the true news, we have Clinton and Trump with the highest number of count. Then for the fake news, you can see that said, Wood, and Mr. has the highest, they have the highest number of count in the data set. And from here, we can conclude that the data is about US politics and to revolve around the past President Donald Trump. And we can see that from the analysis that the New York Times published more fake news than the true news. Therefore, the modeling, we leverage on different models, like almost 7 of them, and from where we choose the best from which we use our CVM as a model for prediction. Then from there, we carry out some analysis on this, and we can see that some of the models perform well. But from here, we can determine that some of this model has almost equal values accuracy. But for us, we choose SVM after checking the differences between them. The model evaluation and comparison, we can see that most of the model also perform well. Then if we talk about the classification report, from here we can see that there is actually almost the data set actually were balanced. So we can see the F1 score of each of them were also balanced. Based on this, we move further to check the confusion metrics. And from here, we conclude that the SVM model has at least error. So we therefore use SVM model to deploy our model. Then also we leverage on the use of neural network. Though this is not our intention, but we just try to use this to just check more on the data set. And we can see that this gave us more accuracy compared to the traditional algorithm. And also, we also try to make use of our local flags to deploy the data and to deploy the model to test if our news is fake or true.
30 seconds.
All right. From here, we can see that these are little flags that we develop, and from here we have some of our news placed there. If the news is placed there, from here we can actually tell if the news is actually fake or true. So from here, we can actually get a news from here and then paste here to confirm if it's true or false. And from here, we can see creating a prediction, then told us that this is a fake news. And then if we further put in more data, we can actually tell if it is also fake or true. Then, all right.
Okay, Shivam.
Okay, thank you. I would just have one question for you.
Okay.
Can you explain me your methodology of data pre-processing? I think it was a text data, right?
All right. During the pre-processing, what we did was, after collecting the data, we clean the data. Then since it is a test data, we need to vectorize. So vectorization there converts some of those tests into vectors. Before then, we carry out what's called stop when we carry out some analysis. I'm sorry. Before then, we actually remove some of those ways that are not actually that is difficult to be used by the model, like some ways which are not found in stop words. We use stop words. We use lemmatization, and also we also use also called vectorization to return the test into vectors, and from there the model were able to work perfectly.
Okay, so you have talked about like you couldn't find a deployment place, so you deployed it on local. So why you guys didn't try it out the Heroku and the other open source tools for the same?
Yeah, we actually plan doing that, but based on the data available, we can be, from the data set, we see that most of the data sets were old news. So for us to be able to deploy this for local for into cloud where people can actually make use of it, we need to train. I mean, we need to be trained data with at least current news so that data can actually so that the builder can actually predict more accurately than using the old news. But currently, we just wanted to use it to just showcase that our model is actually performing well.
Yeah, you just mentioned about in some place that while handling the null values, you just replace it with the empty strings, right?
Yeah, yes, sir.
So during that process, do you think the model could have been affected or something like that?
Yeah, though it wasn't actually though I mean, without if we should drop the null value, it might not really affect the model. But I think putting the dummies like strings will actually make the model perform well because the strings also can be vectorized into a value, which the model can also leverage on. That was why we didn't actually drop the non-values. And the values, the amount of non-values are very small, like very, very small. That was why I didn't drop it. Then we just
Okay, like
use it.
negligible.
Yes.
Okay, good work. Thank you.
All right.
Thank you, Team Kimi. Team Lasso, you can stop. Okay, thank you. Team Lasso, are you guys there? Please share your screen. Team Lasso.
Here.
Okay, your time starts now. You can go ahead.
Hello everybody, we are Team Lasso, and for this premier project, we worked on water quality prediction. I am Soumya Kumari, the first presenter, and I am from India. Our diverse team includes the team lead Sophia, Harshit Saini, my co-presenter, and the rest of the team members who have worked hard to make this project's water quality prediction. Some 3 in 10 people worldwide, or 2.1 billion, lack access to safe, readily available water at home, and 6 in 10, or 4.5 billion, lack safely managed sanitation, according to a report by WHO and UNICEF in 2015. In order to decrease global inequalities, the new Sustainable Development Goals call for ending open defecation and achieving universal access to basic services by 2030. The problem statement is to use the WHO drinking water benchmarks to establish whether the contaminants exceed the safe levels and hence classify if the water is potable or not. Our approach includes deciding about missing values, identifying outliers, determining significant features, and implementing various algorithms. The water quality prediction dataset was downloaded from Kaggle, a crowdsourced platform. It includes 10 different features listed here. It contains water quality metrics for 3,276 different water bodies. We worked on the challenge in subdivisions and used technology like WhatsApp, GitHub, Slack, Google Meet, and Google Docs. Further discussion will be carried out by my co-presenter, Harshit.
Thank you, Soumya. I will take it over from here. As you can see, our workflow process was following. First, we sourced the data from Kaggle. Then we did some data wrangling, basically finding the outlier values and null values in our data set. Then we did data cleaning. Because our data set was quite small, only around 3,000 observations were there, so we couldn't really drop the null values. So we filled them up using the standard statistical processes, particularly using the median values of the feature. After that, we did some exploratory data analysis. We visualized our different features and found their covariance correlations with the water potability to see how much they will affect the model, the final model. Then after that came feature engineering and model pipelining, in which we selected a few best models based on our visualization and the best features to make the model out of that. And after making the models, we did some evaluation metrics and predictive modeling to see how they perform, what is their accuracy, precision, recall values, and so on. As you can see, we chose 6 types of models. They were like the following: logistic regression, random forest, KNN classifier, SVM, decision tree classifier, and naive Bayes classifier. Following were the accuracy values of the different models. As you can see, the random forest model performed the best out of the all the models. Then we did some hyperparameter tuning on the random forest classifier itself, and we did that using grid search CV and random search CV, and the hyperparameters tuned were max depth and estimators, min depth leaf, and they were, yeah, all these 3 hyperparameters were tuned using the random
30
search.
seconds left.
Yeah, after doing the hyperparameter tuning, you can see the evaluation metrics, the accuracy, precision, recall, and F1 value. So finally, we came to the conclusion after doing all the data wrangling, cleaning, and hyperparameter tuning. We still found the random forest classifier to be the best algorithm, followed closely by Gaussian naive Bayes
The time is
algorithm
up.
and logistic regression.
Thank you.
Yes, thank you all. Now we are open to questions.
All right, Kasali.
All right, thank you. So you said the objective of is to use the WHO drinking water benchmarks to establish whether the contaminants exceed the safe levels and hence decide if water is potable or not. So with your conclusion and analysis, can you relate it with the problem statement and tell me what you think?
Okay, so basically the problem statement was to find whether the water is potable or not. By using various classifier algorithms, we have found random forest to be the best algorithm to find whether we can classify the water as potable or not. And as the water has been collected from different water bodies, the samples change, and this is a 2015 statistics. According to that, we are clearly able to classify whether the water is potable or not.
Okay. So last question, like, how can you apply this to like a real life scenario? Like, I mean, if you're given a contract, or if you're being told to apply this project to life scenario, make it something people can use, how would you approach that? Or what is it that you didn't do here that you think you can do better if given the time and the resources?
Okay, what can be done is if the sample is collected from some other body than which is already mentioned, we can use that sample and list out the different like some features we had include pH value, hardness, and from that sample we can calculate that and hence predict if the water is potable or not, and hence determine if it is safe to drink.
Yeah, so where did you get your data from? The data you use, was it from WHO?
Yes, the data is from WHO. It's 2015 statistics.
Okay, all right, thank you.
Thank you very much.
Thank you very much, Simlaso. Main shift, it's a main shift. Please share your screen. Your time starts now.
Cool. Good day, Hamoye panel, and those zoomed in on Zoom and YouTube. My name is David, and I'll be representing the Mean Shift Group and presenting work done on the dataset Consumer Finance Complaints. Presenting alongside me doing questions will be Stefan Asiola, who will be presenting work done by the active members. Regarding the background of the dataset is about complaints from consumers about specific financial products and services. These financial services and products are offered by specific companies in specific states and on specific dates, ranging from 2011 to 2019. When our team sat down and recognized that this dataset came from a financial company giving us data about complaints, we decided that we needed to gain insight on the data to better predict the future occurrences of complaints, to reduce customer dissatisfaction and increase profits. We sat down and came up with some questions and interesting points we wanted to delve deeper into. Things such as insight between of the relationship between issue and product, and diagnosing the rate at which sales increases with issue, meaning the rate at which issues increase relative to sales or decrease in another circumstance, and also the rate of responses of employees to clients that are busy complaining. We started off with some exploratory data analysis to give us a picture of the data to know where to start our data pre-processing. We then moved on to data pre-processing. They did some more exploratory data analysis to get a picture of the data and get some visuals and some understanding of the relationship between different variables. We moved on to model selection and model testing. Finally, we finished with some regression analysis. The first 2 points that we noted was an uneven spread of issue across states. Secondly, was a uneven distribution of issues between different financial products. Second 2 points that we noticed were a periodic increase in issue, meaning there was a general increase in issue per year, and an uneven distribution in the avenue in which consumers chose to log their complaints. Then we moved on to model selection and testing. We trained different classification algorithms, and extra cheese classifier gave us the highest F1 score. We took F1 score as our metric because the test data is imbalanced, and hence accuracy won't be a good measure to check the performance of our data. As the F1 score is close to 1, our model is performing well on test data, and the error is quite low, meaning the company could deploy this model for future prediction. We then decided to move on to some regression analysis. We did some analysis between product and issue, seeing that there was a slightly positive linear correlation between product and issue. We then decided to use a mean shift function to locate the different clusters and modes of data in the case that the company wanted to investigate more on the heavy density on data where there might be a high correlation between possibly a certain product, a certain issue that might have occurred on a certain date. Finally, the last regression we did was regression analysis between the timely response and issue. We saw there's a very slight positive linear correlation between timely responses and issue, meaning that timely responses wasn't necessarily indicative of a customer complaining for a certain issue. At the end of our investigation, we provided an accurate and high-performing predictive model, and we gave a recommendation to the organization for further investigation to know which specific issues are more common with which of each specific product, allowing consumer support employees to be better prepared to support customers. Thank you.
Wonderful. Thank you very much. Shivam, can you please help us access the
Yeah, thank you, team Mean Shift. Can you explain me your problem statement?
So if I go back to our problem statement, I have a mate with me here, Stefan. If you want to answer, you can answer as well. If not, I'll answer.
Okay, good evening. For our problem statement, our goal was to look at the relationship between products offered by these companies and
So can you just tell me something about your data? Like, is it any country specific or what?
Hello, can you hear me?
Yes, I can hear you.
Okay, our data set was actually gotten from Cargo. It's a data set on consumer complaints statistics gotten from the Consumer Finance Complaints of Bureau. It had over 1.2 million observations with 21 features in total. But after pre-processing, we were able to streamline the total observations down to 768 with features of
Okay.
14.
So what I'm just trying to ask is, can you tell me what was the problem statement in one line and how did you deal with that?
Okay, the problem statement was trying to choose the column that asks the question, will customer dispute or raise an issue over a service or product provided by a company? So, and that was what was set aside as a target variable. So we were able to deploy several classifiers, and I think up to 9, and then we were able to settle down for the extra trees classifier, not because of the accuracy, but because of the F1 score. And that was able to lead us to the coefficient matrix, where we were able to streamline our data, and we discovered that our coefficient matrix gave us a true percentage for the false negatives, for the true positives and the true negatives, as compared to the other two variables. So that was how we were able to achieve our results.
Like, what was the conclusion of your project?
Okay, our conclusions was trying to answer the questions whether there's a relationship between specific products and the whether there's a correlation between issues raised by consumers and the products offered. And we're able to, our regression plot was able to affirm that for us. Then the second thing is to examine if there is a correlation between the timely response, of these customers to all these issues raised. And we discovered that most of the issues raised by these consumers were timely responded to. So there's no correlation between that. And for our recommendations, it's that the specific issues that are common to these consumers should be well attended to by these companies. And also that companies should deploy more employees to products, to products that all these customers are likely to raise more of this complaint for.
Thank you.
Yeah.
Shivam. All right. So the next team now is Open TV. Team Open TV. Please
Yes,
share your
hello.
screen.
Good afternoon,
time
everyone.
starts
Can you see my screen?
Yes, please go ahead. Your time has started.
Okay, good afternoon, everyone, or good day, everyone. My name is Arinze Chukwumuba. I am the team leader for Open TV, and I'm presenting from Lagos State. So our project statement was Parkinson's disease detection. It's, as we all know, Parkinson's disease is a neurological disorder that affects the nervous system. The disease is marked by decrease in dopamine level. Although the exact cause is not fully known, we believe that what we've done here today can help us predict if an individual is going to have the disease. So our project workflow started from gathering data from the web, the data wrangling, EDA, the machine learning, and then the model deployment. So as the data descriptions here, the column names, and fellow descriptions. So when we did when we started visualizing data, we found out that there was obviously the data set was imbalanced because of the people that didn't have Parkinson's and the people that did have it. So what we did was we used IMB Learn to upsample the data, and then the heat map shows the correlation with all from status and everything given at the data columns, and the features that were dropped were the ones that were least correlated with with the status. So from the KDE plots, we found out that patients with the disease, the PPE was more clustered on the left side. So moving on, after we used random forests, SVC, KNN, decision tree algorithm, HGB, and light beam regressor models to train the data set. And we found out that the XGBoost classifier performed best, with the highest scores. So after we fine-tuned the model, obviously, and increased the number of N estimators, increased the max depth and the learning rate, and this was what we got. We found out that the true positives were quite high, and the true negatives were also indicative of low. So the F1 score we got was 0.98, which is very close to 1, and the recall, the precision and recall as performance metrics, they also did very well using the XGBoost. And yeah, we had some limitation in the study, obviously, the imbalanced data sets. Then, in conclusion, after trying out several algorithms, yeah, the XGBoost classifier proved to be the best. And the model accuracy of detecting packets was about 98%, F1 scores of 0.98. Meaning that this model can also be deployed by anyone that wants to use the data set to predict Parkinson's disease. Thank you very much. Hello? Can anyone hear me? Hello? Hello?
Yes, we can hear you.
Okay.
So can you just tell me about your problem statement? So you were trying to predict the Parkinson's disease, right?
Yes, we were trying to predict Parkinson's disease.
So can you explain me the features of the data set?
Okay. Well, we had the column names, then the average vocal fundamental frequencies, the PPE, the two nonlinear dynamical complexity measures, the fractal scaling exponent. Basically, the data set was gotten from Kaggle, and these were the different metrics. When you from voice, their vocal patterns, and these were the measures that were taken from the data set, from the patient, and presented as the data set. Yes.
So can you tell me about your modeling approach?
Normally, it was supposed to be a classification problem, so we used logistic regression, but we found out that the XGBoost performed better in all ramifications. So
Can you just explain me your confusion metrics?
Sorry?
Can you explain me this confusion metrics?
Okay. So basically what we did was, after we used
the previous slide, like
previous
the slide after that, the confusion metrics.
This one. Okay. The confusion matrix. Okay, so the true positives were the test results that indicates the presence of the issue, while the true negative, these 35 folks here, correctly indicates the absence of the disease Parkinson's, while the false negatives and false positive, one each, the test results for the false negative, the people that wrongly indicated that the patient had Parkinson's, and the false positive, the test results that indicates that the particular condition, being Parkinson's, was present.
Okay.
Yeah.
So what was your conclusion, and were you able to deploy your model on some platform?
Okay, so we haven't deployed the model yet on Heroku, but we found out that the XGB classifier proved to be good. And since we had high F1 scores, I mean, the model is actually good to go. It will be done on Heroku as soon as possible.
Okay. So are you planning for any improvements in future for this project?
Yes, maybe tweaking the number of N estimators, maybe bringing the number down to Because when using this model 98%, it sounds good, but you really don't know unless you play with some hyperparameters and actually compare and contrast with this present result. So that's what we're going to do.
Okay, thank you.
Thank you very much.
Thank you, Shivam. Okay, so the next team PyTorch. Are you guys there?
Yes.
Yes, I'm here.
Please start presenting.
Okay. Good day, everyone. My name is Samantha Calvert. I'm one of the group presenters for the PyTorch team. The other presenters, Abdurrahman, who seems to be answering the questions of the judges. These are also other active members of the team. Our problem statement is predicting the expected number of days a patient will stay in a hospital, which is difficult to do at times because of clinical and non-clinical factors. Spending a lot of days in the hospital could also lead to increased hospital-acquired patient complications, increased costs for patients and healthcare systems. In addition, prolonged stay in the hospital could also negatively affect both patient and staff experience. So therefore, it was a need to perform predictive analysis that could estimate the patient's length of stay using a machine learning model. An existing method of predicting length of stay is the traditional method, which uses the hospital's average length of stay. And a study done by Intel and Cloudera created AI mechanisms that uses the random forest algorithm. Another study done by Baylor, Scott, and Whitehouse created a tool that processes both structured and unstructured data. So the built-in algorithm learns from every case, enhancing its results over time. So our approach to solving the problem is that we use data sourcing, which involved looking for a data set that could be used for this project, data preparation, which involved activities taken before the model is trained, and these activities are data wrangling, data cleaning, outlier removal, and exploratory data analysis. We also did model training, where the machine learning models were fed with the clean data so that the models could learn the relationship between the feature columns and the target label. We also did model evaluation and validation, where the performance of the model were evaluated immediately after the model was trained. So this linkages the data set that we use coming from the official website of the New York State, and the data contained over 2 million records and 34 features. So what we did to clean the data is we treated some null values, we treated duplicates, we fixed data types, we dropped redundant columns, and we also renamed columns. As part of the EDA, the following box plot shows that some patients stayed up to 120 days in the hospital, which was in contrary to the national average hospital stay of 4.6 days in the US. So some of the readings were considered outliers and they were thus removed from the dataset. The violent plot also shows the following summary: that emergency cases mostly spend between 1 and 6 days on admission, elective cases 1 to 4 days on admission, newborn spend 2 days on admission, sometimes 3 days, and most urgent cases spend 4 days or less, with others staying above 5 days. This box shows that there's significant variation in length of stay across different APR severity of illness, because it indicates that those with extreme cases tend to stay longer than those with minor cases. My colleague Abdurrahman will take you further to the model building process.
Thank you, Samantha. Now to the modeling. 2 models were created by the team, a regression model and a classification model. Because our target variable is a numeric data, a regression model is the best, but we also created a classification model to experiment. We did this by converting the target variable into a multi-class, such that short period stay is 0 to 3 days, medium period stay is 4 to 5 days, and long period stay is beyond 5 days. Feature engineering was used to select the best 10 features that went into the regression model. Next. The regression model was trained on 50,000 records from the data, and we built 3 models: the linear regression, decision tree regressor, and support vector regressor. The support vector regressor performed best with a mean absolute error of 3.81. Next. The classification model on its own was trained on 300,000 records from the data. 4 models were built: logistic regression, decision tree, random forest, and XGBoost. After model tuning, XGBoost performed best with an F1 score of 0.71. Next. This is a graph showing the feature importances of the features that went into the classification. Total cost was the most important feature, and we have some features that weren't so important down the graph. Next. At the end of the project, the team faced challenges regarding scheduling meetings due to difference in time zones, and we were also unable to train the models on the entire data set due to its size. The project will be a contribution such that patients will be aware of how long they will spend on admission, and this will also help them to estimate roughly their bills based on their length of stay. We recommend that the model should be trained on the entire data sets. Other algorithms like AdaBoost can be explored. And also comparing the feature importance, the number of models that go into the training should be reduced to about 5. And other parameters can be explored while tuning the model for better improvements. Thank you.
Your time is up. Thank you very much. Shivam, over to you.
Yeah, thank you, Team PyTorch. So that was a good one. So this is like a very crucial problem statement that you are trying to solve. The number of days a patient has to be there in the hospital. So can you explain me about your data set and your methodology that you adopted?
The data set contains some features about admission of patients. It contains the length of stay, the total cost.
What was the data source?
The data source is from New York's data, hospital data, and it contains hospital inpatients discharges, though they've been de-identified.
All this data is regarding the US and the New York state, right?
It's from the US generally. There are other cities there.
Okay. So how did you treat the null values? What was the method that you thought in your mind?
Looking at the data, we found out there is a column that had more than 80% of its values to be null. So we removed the column entirely because it was almost not useful. It was a numeric column, so we couldn't think of values to inputs. And then there is a categorical column, payment typology, that also contain null values. And then we thought to replace the null values with a string, none, because it's categorical. So it's better than removing it so as not to lose so much data. And then other null values that weren't so much from other columns were removed.
So what is your call on that? Like looking at the data, your data is a lot of duplicate values, a lot of null values. So how can you say that the output of your analysis would be accurate?
The data has close to 2 million records, and then the duplicate is a very small fraction of the entire data, just 31,000. Yes.
Okay. So what would be your further improvements that you have thought about it? And what was your conclusions? Like what was your output of this analysis?
The output of the analysis was just that the models, go to regress models like a classification model. If the model was to use a classification, then we built it such that the short period stay, medium period stay, and long period stay would be predicted for any patients that will be admitted. And if it was to be regression, the exact number of days to be predicted for the patients.
Okay. Okay, thank you. Good work.
Thank you, Shivam. Thank you, Team PyTorch. Random Forest, are you guys there?
Yeah, Random Forest here. I'll just start sharing my screen. Yeah, so I'm on behalf of Random Forest. Okay. Our project is on.
Please.
I've started sharing the screen. I hope everyone can see.
Yes, go on, you can see.
Yes. Yeah, okay. Yeah, so our project is on Airbnb, new user booking prediction. Yeah, so you can meet our team members here. We are 13 of them. So the introduction. So Airbnb is a place where you can book up to 34,000 cities across 190 countries. So by accurately predicting when your user will book their first travel experience, Airbnb can share more personalized content with the community and therefore decrease the time to first booking and better forecast demand. Yeah, so here's a workflow from the problem statement, the data source, the data descriptions, all the way to the conclusion and future work. Yeah, so our problem statements. So the problem is to predict to which country the new user of A and B and B will book his or her first travel experience. Yeah, so our data source. So we acquired all these 5 data sets from the Kaggle website. So we have the train of the users, the test, the sessions, the web sessions log for users, the countries, and the age brackets. Yeah, so on our data description, the train and test data sets, they had a unique user ID, the date account created, the time first active, the date first booking. So in total, there were around 16 features. And the last feature was not the target variable, the country destination. This is where it is the column now on which you're trying to predict. Yeah, so, and since we're using the sessions dataset, so here's a brief description of what the sessions dataset looks like. It has the user ID, the action type, action details, device type, and the seconds elapsed. Yeah, so afterwards, now we move on to the EDA. So we performed univariate, bivariate, and multivariate analysis to better understand the model. So as we are performing our EDA, we came across some null values. The date first booking had the higher percentage of null values, followed by age, followed by first affiliate tract. Also, we noticed that there were some age outliers in our data set. So on the EDA again, we also noticed that there's some preference for younger people where they travel to, and also for older people where they travel to. Yeah, so looking at our country destination, we were trying to predict, so there are 12 actual possible outcomes for destination, but the 11 countries which a user can travel to, and that one other outcome is NDF, which is basically where a user didn't actually make a booking. Yeah, so if you look at our distribution of the country destination, the one which we're trying to predict, you can see that the NDF, where a user didn't actually make a booking, is the most out of all the other categories. Yeah, so also in our categorical features, we can see, like for the first browsers, there were 52 different browsers, there are 25 different languages, and so forth. So now on the data cleaning. So on the data cleaning, since age had some null values and outliers, so we filled both the null and the outliers with the median age. Then we dropped the date first booking column, since on the test data set, they are all none. So it really won't be any use of us. Then for the first affiliate tract, we filled it with forward fill. Yeah, so here you can see the distribution of age before and after removing the outliers. Yeah, now for the sessions data set, for all the categorical features, we replaced them with the mode. And for the second elapsed column, we replaced it with 0. Yeah, so after cleaning our data, now it is time for some feature engineering, encoding, and the machine learning model. Yeah, so first of all, the ID column was not really useful, so we set it as the index. Then the date account created and the timestamp first active columns, we dropped them. Then we used one-hot encoding to all the categorical columns. Yeah, then we used label encoder to the country destination. Yeah, so now when it comes to model building, first we have to discuss the metric used. Yes. Yeah, okay, so on the metric used, so and since we'll be predicting at least 5 destinations where users likely travel to, so the metric that we're going to use is NDCG score. We are not going to be using the normal F1 or the precision scores. Yeah, so after feature engineering, we tested out 3 different classifiers: the KNN classifier, random forest, and gradient boosting. Out of all 3, the gradient boosting.
Your time is up. Thank you.
Thank you.
Basil? Is Basil there? No, then Shivam.
Thank you, Team Random Forest. So you talked about the outliers. So I would like to know how you dealt with that.
Yeah, the outliers of in the age column. So the outliers and the null values, we replace them with the median age.
Okay. And how did you convert your but what was the method that you adopted for label encoding?
Yeah, the label encoding, we used label encoding to encode the target variable since there were 12. But for the other columns, we used one-hot encoding.
Okay. And did you had any plans, like how did you analyze the output for the real world? Were you able to compare it with the real world?
I've not gotten you. Please come again.
Like the output, the analysis of this entire project. Were you able to compare it with the real world analysis, like a real world scenario? Is the output just theoretical, or is it actually comparable to the real world?
Yeah, it was actually comparable. If you look at what you're predicting, since on the training data, most people didn't actually make a booking. So even coming to the predictions, when you are predicting, since we're predicting the 5 most likely destinations, so we can say that not many people will actually make a booking to travel, to take their first flight.
Okay, can you walk me through your matrices?
Yeah, so metrics was the normalized discounted cumulative gain. And this is a metric.
Can you explain me what is this?
Yeah, so it is a metric for recommendation systems. So yeah, and the order of which you're going to predict the target variable is going to matter. So the first prediction will have a higher weight compared to the other predictions. And the normalized discounted gain, now it's a method now for it is a metric now for the recommendation system where you at least where the first prediction will be given a higher weight than the others.
Okay. Yeah, thank you.
Thank you, Shivam. Tim Scrapey.
Yeah, hello. Good afternoon. This is Tim Scrapey.
Please share your screen.
Yeah.
Your time has started.
Please. Can you see my screen, please?
Yes, we can. We can. Your time has started.
All right. So we worked on predicting adult income, as adult income prediction. My team, and the project lead, Kwame Shay Gupta was the assistant, and then Adisa Fikulade was the career analyst, and then we have our active group members also listed here. So our problem statement was to leverage the census data to understand and then predict whether or not an individual will earn more or less than $50,000 per year. We got our data sets from Kaggle, the adult income prediction from the US Census data. So we did data wrangling and then exploration, then a little bit of feature engineering, which involved encoding and then scaling. And then since our data set was imbalanced, we applied smooth balancing. And then we built our models and then evaluated them on some unseen data. So as I said earlier, our data was from 1994 US Census data. We had just about 32,000 observations and then 15 variables, which were a mixture of demographic and economic factors. So we have some of them here: age, working class, education, number of years, marital status, relationship status, race. So for our data wrangling and pre-processing, it had some null values. So we dropped the rows with null values because weights were attached to the rows. And so you wouldn't know exactly what value to impute, because then you would be reinforcing the biases already in the data set. So we decided to drop the rows with the null values. The columns, the names of the columns were renamed and then restricted to alphanumeric values so that at least we can match with Python naming conventions. And then we had a few duplicate column values as well, rows. We dropped them. And then at the end of the cleaning, we had about 30,000 rows to work with. For our exploratory data analysis, we had the data ranging from 17-year-olds to 90-year-olds. There were about 7 unique work classes spread across the public and private, but then majority of them worked in the private sector. And then I think 85% of the observations were from whites as well. And then there were twice as many males in the data set as there were females, which is one bias in itself. So from the demographic insights, we had lots of middle-aged individuals earning about 50,000. That's 36 to 51-year-olds. And then lots of people in the data set had about 10 to 13 years of education. The largest percentage of the observations and about 50,000 were Asian Pacific Islanders. And then people earning by education, people earning about 50,000 were mostly doctorate and then professors in schools, yes. And then as expected from the percentages in the data set, there was a higher percentage of males earning about 50K than females. We had economic insights as well, with most people earning about 50,000, working about 40 to 50 hours. And then most people also had zero capital gains and no capital losses. So anybody earning above 100 in capital gains or losses were outliers. But people who made more capital losses were more likely to earn less than 50,000. So we went on to use one-hot encoding to encode our categoricals. And then due to the mild imbalance in the data set where those n number 50,000 were in the minority, we applied smooth balancing to balance the data set. And then to mitigate the effects of any outliers in the numeric columns, we applied the min-max scalar to bring them within a defined range to make it easier for the models. And we trained the number of models. So initially the data was split into train and then testing, and then the train was further split into train and then test, so that the original test will be used for evaluation, and then the models will be evaluated on train and test. So here is on the train data, we used accuracy, precision, recall, and then the F1 score. We see our light GBM model leading, the XGBoost followed, and then the random forest making the top three. So we selected the light GBM and then the XGBoost to train on the evaluation set. And then the light GBM still the XGBoost. And then here are most important features: age, final weight, hours per week, and then capital gain. Yeah, in summary, light GBM was the best performing model. Age, hours per week, and then education levels were the most influential factors. Yeah, thank you.
All right, thank you, Shivam.
Okay, thank you, Team Scrippy. That was a good one and within time. So can you tell me, how did you select the features, the most important features?
Yeah, so I think from the pandas refiling reports, we noticed some multicollinearity in some of the variables, but then the most influential was education and the education number, which was giving us the same information, because other things being equal, your level of education will determine the number of years you spent in education. So that was the most influential, and then we dropped that column. I think that was the only column that we dropped. Aside that, we maintained everything using a forward selection kind of thing. And then from our top models as well, we noticed that for the different models, different features were important. And so we decided to hold on with what we had done for now. Okay.
And I guess you also had some outliers, right?
For the numerics, yes, a few, but the effects of those were mitigated with the use of the min-max scalar.
And you also talked about the data set in the starting, right? Can you explain what were the features, all the columns?
Yes, so a second. The features in the column were age, the work class, the final weights of. So the final weights, we had education level, education number, that's number of years, the marital status, the occupation, the relationship of the individual, the race, the sex, the amounts they made in capital gains or losses, and then the hours they worked per week, and then their native countries, and then their income group, that's whether above or below 50,000.
Okay, so if we can we say this from your analysis, that if a person is spending more number of years on education, he is more likely to earn more than $50,000 an annum, right? Per annum.
Well, looking at the weights, the feature importances from our best model, education is the number of years in education was the fifth most important feature. So to an extent, yes, but it is not the most influential.
Okay, so which means like you are able to connect your analysis with the real world also.
Yes, please.
Okay, that's good. Thank you.
All right, thank you, Shivam. Team SourceForge.
All right, thank you.
Please share your screen. Your time starts now.
So hello, we are SourceForge presenting linking molecule characteristics with biological responses. So the team, the presenters are Rogers Mugambi and Nimat Ibrahim, supported by the other 6 members. So we aim to contribute to the improvement of understanding of the principles that underlie biological dynamics and function by developing a prediction system that will predict with high probability the ability of a molecule to portray a specified biological response and also identify the most influential molecular features. So to do that, we evaluated the project brief, then we undertook exploratory data analysis, followed by feature engineering. Then thereafter, we started the modeling process, within which we tuned the parameters, and then selecting the best model, we used it to develop a prediction system, which we deployed. So the data we sourced from Kaggle, the data was already normalized and anonymized. So the data composed of 1776 independent features, of which 834 were identified to be binary and the others continuous. Also, there were that 751 are observations, and the dependent variable activity was identified to be binary. So therefore, we applied classification algorithms. So to start off, we checked for class imbalance, and with 8.45%, we saw that there was no need for corrective action because it was approximately balanced. Next, we checked the distribution of the features. To the left chart is for the binary features, and for the right chart is for the continuous features. Also, checking for outliers, we realized that 882 out of the 942 continuous independent features had outliers, and the mitigation measure was regularization, even though the performance increase was marginal. So then we also checked and saw that the molecules could be grouped into 33 optimal clusters. And with that one, I invite Nimat to continue with the model development and beyond.
All right, thank you, Rogers. I'll be taking over from you. So the first thing we did was to train our data set on 10 classification algorithms without setting the parameters. That is, we use the default parameters, and we use log-loss score to check the performance of the model. Note, however, that when using log-loss, the lower the score, the better the model. So random forest and XGBoost give us the lowest log-loss score when we test it on the unseen data. So we chose these 2 models. And after we choose the 2 models and tune their parameters. After tuning the parameters, random forest gave us the lowest log score of 0.41 when we tested it on the unseen data. So we use random forest to develop our prediction system. So these are the 10 important features according to random forest, from the least important to the most important. So after developing our prediction system, we use it to build a web app that was hosted on Streamlit, where anyone can make predictions, where anyone can predict biological response to molecular characteristics from anywhere in the world. So this is the interface of our web app, both on Android and on a desktop device. So this particular prediction system can be applied both in medicine and in bioproduction for predicting biological response to molecular characteristics. And we recommend that other techniques such as deep learning, as well as provision of a larger pool of data, can be used to improve the performance of the model and to make better predictions. All right, thank you for listening. And the next slide is a QR code that can be scanned by anyone, and it will take you directly to the web app where there are further instructions on how to use the app. Thank you very much.
All right, thank you. Shiron?
Thank you, Team SourceForge. So I just scanned this QR code and I was able to see the app. So can you explain me first the problem statement?
Okay, so the problem statement, we were provided with
in a very simpler
several-
terms, like
in simpler terms.
what was a problem statement and what you did.
Okay, basically we are investigating which features of a molecule will influence a biological response, and which molecules will influence a biological response. So for example, in cancer, which molecule can cause cancer, which one cannot, and which features are the
So
main.
can you
causes.
just go back to this top 10 features slide? You were showing me a bar chart. Yeah, this. Yeah. Can you explain me this D20, D1067?
Okay, so basically, we took the top 10 important features, and D27 had the most importance. But these features are already anonymized, so we just have them as D27. We have them as these codes. But for this 10, the most important is D27, and the least important is D20 within the top 10 features.
Okay, so my question is that what is this D20 and D27?
We were not provided because it was anonymized from the source.
Okay, that's fine. So the problem statement you are trying to achieve is you are able to. Sorry, what?
Okay, I thought you were asking me.
Yeah.
Hello.
I was just asking what was you trying to predict?
Okay, yeah. So we are trying. It was two-pronged. We are trying to identify the most important molecular features that will influence the biological response, and also which molecules influence, like have which response in general.
Okay. Can you explain me the working of the app? It is quite well made. The Streamlit app.
Yes. Okay. Unless I bring it up. Or okay, I've not gotten you correctly.
Yeah, I was saying, can you just walk me through the app?
Oh, so if you allow me, I can share my screen of the app. Just 1 minute. So basically, okay, with this app, first there are two sides, the visual corner. So we put a visualization for the class balance. So as to show the user like the classes were almost balanced. And then next, there's this feature where a user can see the histogram or the distribution of any of the features that we evaluated. Let's say if you want D175, so it will run. So here it's histogram, and here is a value plot.
Okay, got it. Yeah, thank you. Good work.
So also there's a most important features. There's a snapshot of the top 20, but also you can download the whole list of the importance of the features.
Okay, we are just short of time. Yeah, thank you.
So then there's a predict.
Good work.
Thank you.
Okay.
Up to the next team, spectral clustering. Can you guys please share your screen? I'm about to start your time. Spectral clustering team. Okay, your time has started.
Good day, judges. Good day, everyone. Good day, my fellow colleague. Please trying to work this out. All right. Good day, everyone. Good day, my fellow colleague, once more. So I'll be presenting for spectral clustering, and our topic is HR analytics about the job change of data data scientists. Our team, I myself am the presenter and the query analyst, and presenting with me as well is Ugona and the other active members. So we have our problem statement. Will train data scientists change their jobs after the training or not? So a company is basically looking at training candidates and saying if after the training they would leave or they would stay after the training. So our approach towards that, we had to get our data from Kaggle, then we visualized our data, and we had our categorical data and our numerical data. Then we have our data processing, model training, and model validation. From here, we can deduce that our data set was designed to understand the factors that led to people leaving their job, leaving their job to a new job, and we had non-values were replaced with the mean of the respective columns, and our categorical variables were encoded using label encoding, and we had various variables in the data set that were plotted against the target variables using Seaborn. So I'll go ahead to display our data visualization. This is a plot of the gender versus the targets, and we could deduce that we have more of the male gender in our data set than the female gender, and the type of candidates we have are those that has relevant experience as against those with no relevant experience. We have those that we have less people that are enrolled currently in a full-time university, and we have the people that are average, at least most of our candidates are graduates. Then we have the major discipline. We deduce that our candidates were from the STEM discipline. Then the company size was a medium-sized company, and basically these are our data visualization. I would hand over to my other colleague who go now on the call to take us through the data modeling. And
okay, Joshua, thank you. Okay, I'll continue from where Joshua stopped. So Joshua, you can just keep up with the slideshow. So our heat map shows the correlation between the several fixtures on our feature columns on our data sets, and we try to map out the relationship between each feature with the target column. And we discovered that our data has some level of imbalance. So our target data has target column has a level of imbalance. So we decided to work on that. Can you please show the next slide? So we decided to work on that, and then we use the smooth technique to correct that. And after correcting that, and we used several algorithms like the random forest classifier, the edge boost, the logistic regression, naive bias, support vector machine, and we realized that of all these algorithms, hold on, go back to this. We realized that of all these algorithms that we use, that the random forest classifier gave us the best prediction that we actually needed. So we took the random forest classifier and we did hyperparameter tuning on it, and we discovered that the result that we got after the hyperparameter tuning and the previous result that we got were actually the same. So we worked with the random forest classifier. Are you going next? Okay, go to the next.
The time is almost up.
So, okay, these are confusion matrix. Confusion matrix shows true positive and true negative, and false positive and false negative, and the difference between the predicted and the actual data. And if you check through, you realize that there is no much difference between
Sorry,
the
your time is
predicted.
up. Thank you. Shivam.
Yeah, thank you, team spectral clustering, right? So you have a very interesting problem statement to tackle, job change of data scientist. So what was the data set about? Am I audible?
Yeah, so our data, can you hear me?
Yes, I can hear you.
So our data set was about a company that is active in data that wants to hire data scientists and people that have gone through their course, people that have gone through their training, and they are looking for a new employment. Are these people going to stay after the training, or they are looking for a new employment? They just want to get trained to go and look for other jobs, or trained to work for that same company. So that was what about our data set, and we had different features. We had the experience level features. We had the school.
So just sorry for disturbing you in between. You have mentioned about the null values were replaced with the mean of the respective columns. So why mean? Why not median? Why not mode?
Used for the numerical variables, we use the mean. While for the categorical variables, we replaced our non-values with the mode, the highest occurrence in our data.
Okay. So what was your conclusion of the analysis?
With different features, with the outcome of this analysis is that it's just basically demonstrate that we can use machine learning to detect whether a candidate will stay after a training, but that depends on the features. Especially, we noticed that the relevant experience of the candidates, the last new job, those were the key features that determined if a candidate would stay after the training or not. Thank you.
Okay. Thank you. Good work.
Thank you.
Team Tableau.
Yeah, let me share my screen.
Yes, please. Team Tableau, your time has started.
Can you see my screen?
Yes, please go ahead.
Yeah. So our this is our project. It is based on house pricing in AMS. It's a place in US. So these are our team members. I really appreciate the hard work of our team members. And our problem statement was to find out the sales price in relation to the specific features of the house. And so this is our project workflow. So initially we followed a standard method of cleaning the data. Like the first method was to prepare the data, in which we did all the cleaning part. Then we build a model, and in the final step we communicated the result, in which we visualize our data set. And this is our data description. We have 81 features. After cleaning, we got 81 features and 1,460 rows. And in our cleaning data cleaning process, 60% of we set a threshold for dropping the columns. So there was 60% null values that we dropped. And we also dropped the columns which have high and low cardinality in the data set. And also we looked at the features which were having very low correlation, or which were not having any correlation with the sales price. So we dropped that column, and our target feature was the sale price. This is our coding part that we used a wrangle function in the coding part to clean the data. And this is our correlation. This is a heat map which shows the relation between different features of our data set. The highest correlation was found in overall quality of the house. And this is our violent plot. which shows the relationship between overall quality of the house and the sales price. On the y-axis, you can see that there are sales prices. On the x-axis, we have overall quality. The house with only one rating has the sales price less than $200,000. The house with pricing more than rating more than 10, which is 10, has a price more than $800,000. And you can see that we also created a relationship between sales price and garage size. Where the house which have 3 garages, which can store cars, which can store up to 3 cars, has the highest price in our data set. And you can see that we also found that relationship between sales price and square feet of the house. So the higher the square feet of the house, the higher the sales price of the house. In this, we can see that in this bar graph, we can see that during the month of June and July, there was highest number of houses that was sold, right? You can see that on the right, we have these colors. So there were 42 independent numerical features that we use. Then what we did is we split the data set into a training set and a test set. Then we also perform mean absolute error on a baseline model. Then we implemented our actual model, which were linear regression, lasso regression, gradient boost, and XGBoost, and so on. We also performed mean absolute error on this as well. So this is a model training pipeline code. So what we did is we tried to find out the relationship between y test, y actual, and y predicted. As you can see that there is a regressive line which shows the best fit in the model, and you can see that there are different variations in the observation for different graphs. And these were the values that we calculated for error matrix. So XGBoost regression has the highest accuracy, and the R2 score for the XGBoost was highest, which means that this model was the best XGBoost regression. And we also created a simple web application so that in case so that it looks realistic. In case if I am running a real estate company, so if a user wants to access the information, he just click on the website, and here he enters the quality of the house. Let's say if the quality of the house is 5 and rating of the overall condition of the house is 5, and a year of original construction, let's say 2005, and when he click on estimate, he will get the price of the house, the predicted price of the house, which is 6156.1875. So that's it for this project.
Okay, Shivam.
So thank you, Team Chablu. It was a good one. And I was also able to see app. So can you first describe me about the data cleaning issues that you faced, or there were no issues?
There were issues in our data. There were a lot of missing values, and there were high cardinality in our data set. So initially we set a threshold, because when we were dropping all the null values, what happened was that we were losing some good features in our data set. So what we did is we set a threshold, like we will only drop the 60% of the missing values, NA values, and also the high cardinality data, which was very useless for us. So we dropped that.
So were the prices that you got, were this comparable with the real world?
Yeah.
Okay. At the same time, what was your entire thought process for the method, for the modeling?
Thought process? You mean thought process?
Yeah, end to end for modeling.
So we implemented advanced regression techniques in our model to find out the best accurate regression model. Like we used linear regression, RG, and XGBoost. So among them, we got the XGBoost regression as the best model, and which gave us the high accuracy.
Okay.
And then what we did is we used that model and deployed XGBoost as our base model, and we deployed on the internet. And then we can, from there, we got very realistic.
So were you able to achieve your problem statement?
Yeah.
Okay. Thank you. Good work.
Thank you, Shivam. Team XGBoost, the last thing for today. Team XGBoost.
Okay, thank you very much.
Please share your screen.
Can you see my screen?
Yes, your time has started.
So thank you once again. My name is Elijah. I'm representing the XG Boost group on football event analysis. I'm the project lead. We shall be presenting together with the assistant, who is Omar. These are the active members. So what was our aims and objectives? The aim of the project is to develop a machine learning model to predict whether a goal will occur or not based on several events, which are collocation of the ball, body part assist method, whether it's a corner, free kick or open play, and also finally short plays. What was our approach? Exploratory data analysis, data wrangling and preparation, goal prediction idea was also formed, and finally we did a model. We built a model. We got our data from Cargo. Our data was provides a granular view of 9,074 games, totaling to 941,009 events from the biggest 5 European football leagues from 2011 to 2017. We did for data preparation, we did data wrangling and data processing. So let's dive into the analysis part of our presentation. As you can see from this graph here, most of the goals are scored around the half time, that is 45 minutes plus extra time, and around full time, 90 minutes plus extra time. That is when most goals are scored. On the right, we have the graph of analysis between the goals for home and away team. As you can see, the blue is the home goals. And for every minute, most of the goals scored are by the home side. This supports the general notion that the home side has a statistical advantage. So next we have the analysis of how goals are scored. As you can see, 55.0% of the goals are scored using the right foot. 27.6 are scored using the left foot. 17.3 are scored using the header. So then we go to the percentage of each situation for goals. About 70.8% of the goals are scored from the open play. Let's go to the percentage of goals scored by location of the shoot. Most of the goals scored are attempted from around the box. That is 64.5%. And cross range follows with 19.4%. Let's go to the analysis of the red cards. Number of red cards again is time during the match. As you can see, around the 90 minutes, that is the time where the largest number of red cards are issued. It makes sense as the players will get more emotional and the atmosphere would be more tense towards the end of the game. Also, you can see that the away team is more likely to get red cards. This is also a case with the yellow cards. Analysis of attempts against goals. From the conversion rates, we can see that it takes Messi more than 4 attempts on goals to score, whereas it takes Ronaldo 6 attempts to score. Of the 10, Diego Costa has the best conversion rate, meaning that he's the deadliest attacker of the 10. So next, I will welcome my co-presenter, who is Omar, to talk about.
Hello, everyone. My name is Omar. I'm going to be talking about model training. And the first part here is, as you can see, the model building workflow. So the first part would be the data preparation, of course. So we search for the non-values in here, and as we can see in the before and after. After we did the data cleaning, non-values removal, we can see we have no longer null values. The next part would be selecting feature variables and target variables, which is for the feature variables, we consider time and location, body part we used to shoot the ball, and which assist method, situation, whether it was a corner or a free kick, and also a side and a short place. I forgot to mention the response variable was is goal, the outcome of whether it's a goal or not. The third part would be the train test data splitting and
30
data.
seconds left.
Okay, so we use the 30% test size, and then for the data balancing, we checked that we have seen that 10% of the shots were only goals, which is not balanced. So next we did kind of balancing the data by undersampling. So only 30%, now 30% of the shots. Now we go for the feature engineering. We use one-hot encoding.
Time is up. Your time is up. Thank you.
Yeah.
Okay, Shivam.
Yeah, thank you, Team XG Boost. So I just have a couple of questions for you. Can you explain me your feature set?
Yeah, of course. The feature set that we had here. Let me. Can you go back? No, go back. Yeah, here. So the feature set here, the time means the time where the shot occurred, like when the player shot the ball. The location of the ball, location is the location of the ball on the field where the shot gets shot. And the body
Okay.
part,
Can you just
which
tell
body
me
part,
about this
like
assist method feature? Assist method.
assist method feature. Assist method feature, which is like the method that was used, whether it was a pass or a cross or a head pass or a throw
Okay.
ball. This is the assist.
And you talked about your model evaluation. Can you just explain me your
Yeah.
ROC curve?
Yeah. So we used four models, and gradient boosting was the best in here. And as you can see, IOC score. Sorry, we got 88% in here. Can you go for the ROC, please, Elijah? Yeah, here. So this was the ROC curve in here, which is quite good, I believe.
Okay. And you have also talked about balancing the data, and you talked about undersampling it. So
Yeah,
what was the thought process behind that?
We used the normal sampling. We took 50,000 of the 50,000 sample from the non-scores, because I thought that using stratified K-fold or making it 100% balance would be not realistic. And so I think about 30% to 70%.
Okay, so what was the
It's
conclusion
better.
of your analysis?
The conclusion of the analysis that we can detect, we can predict whether a shot is gonna result a goal by
Okay,
these
short
features that
place.
we got.
According to your analysis, the short place is the highest effect on goal prediction.
Yeah, exactly.
Okay.
So for
So do
next,
you have any plans to improve this project
yeah,
further?
exactly. It's written here. I was thinking about adding the player or the team as a feature also, like a player performance or team performance based on the previous goals or their
And
previous
did you guys
statistics.
try to deploy this model on some platform?
Not really, no, not yet.
Okay. Yeah, good work. Thank you.
Thank you very much. Thank you for listening.
Thank you
All
very
right.
much.
Thank you. Yeah. Okay. That'll be all for today. Is Christian there? Mercy.
Yeah, thank you very much, Daniel. That was a very wonderful presentation by all the teams.
Okay.
Yeah. From now, I'll be handing over to Ayene for the closing remarks now. Ayene?
All right. Thanks to everyone who came out. Thanks to everyone who presented. Thanks to our judges. Shivam, thank you so much for taking up the space of two judges. We were supposed to just do one. We're really grateful for that. Thanks to Daniel, who also moderated, and everyone who came out to support their team members. that will be the end of today's presentation. Everyone should stay tuned for more information about the internship and the progression from here. And enjoy the Christmas break and the New Year break as well. All right, that will be the end of it for today. Thank you, everyone. Bye-bye.